All right. So let's start. So previous lectures, we already look at into correlation and simple linear regression. So under correlation, there are three methods can be used to determine correlation between two variables, right? So we have looked into a scatter plot or scatter diagram, right? So kau nampak kat sini, right? And then the second method, which is Pearson product moment coefficient of correlation. So this method gives us the value of R, which is indicate the strength or of the relationship between two variables, right? So another method is Spearman rank coefficient of correlation. So for Spearman rank coefficient of correlation, it's utilize the ranking system in the data set. So when we do a ranking, then we calculate the difference of rank, and then we will get the value of R, which also indicate the strength of relationship between two variables, right? So the condition here, when you want to apply a Pearson product moment coefficient of correlation, there should be a two numerical variable, right? For Spearman rank coefficient of correlation, it can be a two numerical variable or at least ordinal scale variable, right? Ordinal scale variable means that it can be a categorical variable, at least an ordinal scale variable. Right, now let's look at Spearman rank coefficient of correlation. Before we go to Spearman rank, let's revise back the strength of correlation. Right, when the value of R is equal to 1, right, it means that it's a perfect correlation. Right, it doesn't care between negative or positive sign. When the value of R is equal to 1, then it's indicate a perfect correlation. When the value of R is between 0.75 until 1 is a strong correlation, right? When we have a negative 0.75 means that it's a strong negative correlation, right? When the value of R is equal to 0 means that there are no correlation at all, right? So we are measuring linear correlation, right? So now let's look at Spearman rank coefficient of correlation. So now if you can see here, not all times given variable are quantitative, right? So if one of the variable of all or all of the two variable are qualitative, and it means that at least ordinal scale, so then Spearman rank coefficient of correlation can be used. So this rank coefficient of correlation can be used if two given variable also quantitative. So in Spearman rank, we can use either when we have two quantitative variable or two qualitative variable. It can be used either on quantitative or qualitative variable. So for qualitative variable, it should be at least ordinal scale, right? So the formula for calculating Spearman rank is R for Spearman 1 minus 6 multiplied with summation of D squared. So D squared means that the difference of between the rank, right? The difference between the rank. So n is the number of observation, and then n squared minus 1. So this is the formula for Spearman rank correlation. So normally Spearman rank, the symbol is rho equal to 1 minus 6 multiplied with summation of D squared divided by n squared minus 1. So this is the symbol for Spearman rank is rho normally lah, right? If you want to use RS also can. So the computation of RS or Spearman rank is simple since it does not use actual value of the data. Instead, it uses rank of the data, right? Okay, now let's look at example number 4.2, right? In example number 4.2, so the data below shows that the marks obtained by 8 students, so n equal to 8, in statistics test and accounting test. So we want to know, is there any relationship between the marks uh, in two tests using rank correlation? So in this case, we have a quantitative data. So we have this is x1, this is x2, accounting marks and statistics marks. So these variable are quantitative variable, right? So to calculate the correlation, right, we need to create a rank column. So we need to create a rank column for statistics. So this is R for statistics. Another one is R for accounting, right? So we have two additional column. So rank for statistics and rank for um, accounting. Right. So now, when you want to do a ranking, so we will rank from the highest to the lowest. Right? Mean highest got rank number 1, second highest rank number 2, and the lowest get the lowest rank. The lowest value got the lowest rank lah. Right? So the highest value here is 95. So 95 got number 1 lah. This is the rank. Second is 87, 87 number 2, and then number 3 is 79, and number 4 would be 65, number 5 would be 60, is it? Yep. And then number 6 will be 64, number 7 48, and number 8 is 48 and 46. Boleh faham tak how I rank this one? Boleh faham? Can you speak up? How we rank the for statistics here. So we rank from the highest value, which is 95, got rank number 1. The second highest, which is 87, got number 2, until the lowest, which is 46, got the lowest rank value, right? So we do the same thing for accounting. So for accounting, the highest value we have is 82. So now here we have 82, we have two numbers, right? So this one going to be number 1 and number 2. So the rank for 82 will be 1 plus 2 divided by 2, right, which is 1.5. So it will share the same rank number, rank value. So 1.5. The second lowest is 72. 72 is number. This is this is 1. This is 2. 72 is number 3. So it's going to be rank number 3, right? And then the next lowest is 68, which is rank number 4. 65 is rank number 5, and then 61 is number 6, and this is number 7 and number 8, right? Do you understand the concept of ranking the number when you have a two same number, right? So kita letak sini 1 dekat sini 2, right? So 1 plus 2 divided by 2, is 1.5. So 82 will have 1.5 ranking number. So the next number is, this is 1, this is 2. 72 is starting from 3. So 72 is rank number 3. So now we already calculate the value of rank, right? So based on the formula, right, rho is equal to 1 minus 6 multiplied with summation of d square. So d square is the difference between rank. So now we need to create a new column, right, which is we want to calculate the value of d. The value of d is the difference between ranks, right? So d. So d, let's say we take RS minus RA, right? Rank for statistics minus rank for accounting. But actually it doesn't matter. When you want to take rank for accounting minus rank for statistics also can, right? Because at the end we will take a d square of d, right? It will still get the positive value. So now let's say we take RS minus RA, which is 2 minus 1.5 is equal to 0.5, and this one should be equal to 1, 3, and this is negative 0.5, and this is 0, this is 1, this is negative 4, and this is negative 1. And then we take d squared, which is 0.5 squared is 0.25. This is 1, 9, 0.25, 0, 1, 16, and 1. Right? By looking at the formula, RS is equal to 1 minus summation of, so 6 multiplied with summation of d squared divided by n squared minus 1. Right? So this is the formula. So we require to calculate the summation of d squared. So we need to total up all the value of d squared here. So it should be summation of d squared equal to 28.5. So now we can calculate the value of RS, which is 1 minus 6 multiplied with 28.5 divided by our n is equal to 8, multiply with n squared is 64 minus 1, right? So you will get the value of 0.66. So this is a positive value. So we can say that there is a moderate positive correlation between marks, statistics marks, and accounting marks, right? Boleh? Do you understand? Any questions so far? Kejap Allah. Alright. Boleh Ada soalan tak?
Boleh, sir.
Tak ada Alright. Now let's look at the next question, right? Okay. So in this example, we have two categorical variable. It's a qualitative variable. Compared to example number 4.2, we have a quantitative variable. For example number 4.3, we have a qualitative variable, and this is a ordinal scale for statistics and accounting, right? So it's the same example actually, but I just convert it to a grade scale. So we have 8 students in statistic test and accounting test. So we want to know, is there any relationship between the score? right, by using rank correlation, right? So you just mentioned rank correlation means that we want to calculate using a Spearman rank correlation, right? If you want to find a correlation, right, so we just use Pearson product moment correlation. But we need to remember, for Pearson product moment correlation, we cannot calculate for qualitative variable. So now, as usual, I look at the formula. RS is equal to 1 minus 6 multiplied with summation of d squared divided by n multiplied with n squared minus 1. So we need to create a column for ranking for statistics as well as for accounting, right? So we will start from the first value, which is A, will represent the highest value, right? So now let's look at A. A, we have 1 and 2, right? We have two value. 1 plus 2 divided by 2 is 1.5. So A will share the same value of ranking, which is 1.5. And then we look at B, right? So B, we have 1, 2, 3, 4. So after we already calculate for A, we have 1 and 2. So B will start from 3, 4, 5, and 6. So 3 plus 4 plus 5 plus 6 divided by 4. So we will get 4 point. Kita dapat berapa? 4.5, right? So we will put it as 4.5. So for C, it will start from, this is ending from 6 kan? C dia akan dapat start from 7 lah. So 7 and 8, right? Okay. So let's look at for accounting, right? So accounting A, we have 1, 2, 3. So 1 plus 2 plus 3 divided by 3. So we will get 2 lah, right? 1 plus 2 is 3, 3 plus 3 is 6, 6 divided by 3, 2. So this one 2, 2 and 2, right? Then B, we have only 1, so this is going to be 4, right? And for C, this is 4. C, we have 5, 6, 7. So C is 5 plus 6 plus 7 divided by 3. So it's going to be equal to 6.
6.
Yep. And this is going to be 8. Okay. So I hope you understand how the ranking process is working, right? So next, we will create another column which will represent D and D squared, right? So this one, it doesn't matter where you want to minus subtract, whether you want to take RS minus RA or RA minus RS. So let's look at this one, RS minus RA. So 1.5 minus 4 is going to be negative 2.5. This is 1. This is 2.5. This is negative 1.5. 8 minus 8 is equal to 0. This is negative 0.5. This is negative 1.5. And last one is 2.5. Right? And then we square the value of D, which is 6.25, which is 2.5 squared is 6.25. This is 1. This is also 6.25. and this is 2.25, this is 0, 0.25, this is 2.25, and the last one is 6.25. So the summation of d squared will be 24.5. Right? So then we just plug in the value into the formula. So RS will be 1 minus 6 multiplied with 24.5 divided by, we have 8 students, so 64 minus 1. So this one should be equal to 0.708. So 0.708 will indicate a moderate. So moderate, kita tengok 0.7 is a moderate strong correlation. Right? Any question? Do you get it? Ada soalan tak?
Thank you, sir. Boleh faham, sir.
Alright, good. So I think that's all for chapter number 5. I check for. So that's it for our subject lah, topic in our syllabus. So we have covered for scatter diagram, Pearson product moment correlation, Spearman rank correlation coefficient, and we also look at into linear regression, which is simple linear regression using least square method. Right? Basically, I have shown you in previous lecture video using a least square method lah, right? And we already look at how to fit the model and interpret the slope and intercept of the equation, right? So please do expect your test number 2. Your test number 2 will cover from a spatial discrete probability distribution until spatial continuous distribution. Right, so it covers discrete and probability distribution and continuous probability distribution. Right, so 2 topics only. So your test will be on this Friday, right? Is it? I pun tak ingat. Oh, this Saturday. Kan?
Is it?
Okay. So, you want to discuss on past year question, or you just want to focus on your quiz, your test number 2 right now? So, I think for discussion, we will look next week after your test. Right now, please focus on chapter discrete probability distribution and continuous probability distribution. So because these 2 topics will be in your test number 2, right? So I think that's all for today. I just want to cover Spearman rank coefficient of correlation, right?